The composite ARF CARF F-100, also referred to by many as the Hun. Now this full-size aircraft has a drag chute. This model aircraft doesn't currently have a drag chute, so let's fix that. All right, so this is the F-100 rear part of the fuselage, and the chute comes out right in this area right here. So it's a bit of an interesting setup on this aircraft. Basically these flaps here, there's a cable coming out, or these doors I guess, there's a cable coming out right there, and the cable goes up the fuselage, and that's the reason for this. I'm assuming it's just like reinforcement panels. Comes up the fuselage and hooks into the top part right there. So it's definitely a unique setup. The kit didn't come with anything for the chute, and this is the only thing that it came with. So this flexible panel of what I would say is replacement doors. So that's all we got. It's going to be an interesting one. Carlos at CM Jets is making us a chute, I believe, and looking forward to seeing that. So I don't suspect we'll see that chute during this video portion of the build, but of course we will see that during the maiden of this aircraft. So it's an interesting setup. I'm fortunate that we did the BVM aircraft where we had the opportunity to work on and see the chute in the BVM, so we can replicate that as best as possible on this setup. So it's going to be an interesting one. Let's see what we can make work. So essentially what happens is, this is kind of the way the BVM worked. These doors were hinged like this. There was pins that held the front portion of these doors in. So that's one thing we have to think about. Now I've already taken a look at this, and the horizontal stab, when it moves full deflection, it doesn't come close to this bottom portion, and there is a cutout right here as well too. So we could actually have some rods coming through and repeat that same step. Now the owner of this aircraft doesn't take the horizontal stab off, which is good because that means that we don't need to necessarily make those rods removable. We'll take a look at making them removable in some fashion, but yeah, if the horizontal stab's always staying on, it's not something we really need to worry about too much. Maybe we can make them removable by having the servo mounted in this type of area, and those wires that actuate them be removable, so they can at least be pulled back or forward a little bit to clear this area. So the metal cable that the chute attaches to, the doors kind of just sit there with the back end here kind of flapped open a little bit, and that cable just comes out and goes upwards. So that's how this whole system works. Now when we take a look at inside the aircraft, it's this area right here. So obviously we want to make sure we're avoiding the tailpipe. We got to keep that in mind. And we kind of have to build a box in this area that has an angle to it so it's clear of the pipe. Now, one of the critical things with that box is it needs to have sort of what you would call a plunger system. So if you imagine the box roof like this, below the roof is a spring-loaded shelf, and that spring loaded shelf is pressured outwards. So when those pins that hold the door closed move, the doors open, and the pressure plate pushes the chute out. That's the way that that chute mechanism works on this plane, or that's the way that the BVM worked, and we're probably going to replicate that process. So let's do a little drawing here, and I'll show you guys what I'm thinking. So if we're taking a back side view of this chute mechanism, basically we're going to have it sitting in the fuselage sort of like this. Kind of envision something like that. Maybe we have a pivot here. We've got a flapper like this. That flapper will need to be sized appropriately so it can move all the way down like that. And maybe that flapper is spring-loaded on the pivot, right? So maybe we've got a arm that comes off like this, that goes up to a point like that, and this is a spring, so it's got tension pushing that down. That's kind of the simplest thing that I'm thinking about, and then of course if you look at a 3D view, it's going to look something like that. So Yeah, so that's pretty much what we're after as far as the design goes. Now I am not really sure if I'm gonna build this out of wood or 3D print it. Just thinking about this, if we 3D print it, that back end area is likely to get sort of warm. So we would have to use a higher temperature material, which isn't a problem. It just takes a while to 3D print that stuff. If we build it out of wood, then it's going to be heat resistant, it's going to be durable, we don't have to worry about the heat, and of course we can kind of make our design a one-off type thing. So I'm going to give it a little bit of thought. What I'm probably going to do in the meantime is get that pipe installed so we can get some rough measurements on getting this chute box built. To get an idea of what kind of shape and stuff we're playing with here, I did a little mock-up with some cardboard just to kind of wrap my head around how everything's going to visually look. So did that, not really, didn't solve anything or wasn't the solution to anything, but it's done. So I've been doing a bunch of thinking on this, and I think what we're going to do is we are going to just cut this portion out first, get that over with. So need to have this removed so we can start making our box to hold the chute. The other thing we're going to do is we are going to keep the doors underneath that former work intact. So the existing doors, I'm just going to measure that out, and we're going to draw a line across, and that's the line we're going to use. So this portion of the door will stay intact, and then it's highly likely with keeping this portion intact that we can reuse these pieces. I like that idea because these pieces are also fairly thick, but I don't know yet if that's the solution or if we'll end up using these guys. So we'll see how that works out, but we'll pull the Dremel out and we'll start to get this this cut. So when I cut this kind of thing, I either like to use a razor saw, so the hand razor saw, like these guys, or Zona saws as they're often referred to as. So those are nice to use. And the other thing I've started using recently is a diamond bit for Dremel. So the nice thing about the diamond bit is it's just as thin as the really thin discs for the Dremel, but this is way stronger. So the really thin discs are the 409 discs, and they're very, very thin profile to them. So that's what I would use, but this Dremel diamond bit is actually thinner than those guys. So we're gonna get this, this line drawn across, and then we'll come in here and we will do our cutouts. Of course, when you're doing this kind of thing, you wanna have a vacuum, a mask, protection on, making sure that you're not getting or breathing in that dust. All right guys, so I measured the thickness of our former, and the thickness of the former was about 6.15, somewhere in that range. And then what I did was I took our calipers, butted up like this, and the face of the former was 11.5. Then we add 6 to that, so we're 17.5. So we'll just go about 17.5, lock it down. And then from the front face here, if I go like this, we are in front of that rivet right there. So then what I did was I took our flexible ruler, visually got this straight because we're a little bit past, which is fine, and drew a line with a Sharpie. So now what I'm going to do is I'm going to take my diamond bit, and this is going to be our line between the doors that open and close and the fixed piece underneath the former. The former is right on that rivet line right there. We want to keep that intact. All right, so I like to get most of the way through. I'm going to leave the center because we can cut that out at any time. And I'm going to finish this off with my Zona saw. So we're probably pretty much through everywhere except the corners. I don't want to overshoot the corners, so I just leave it a little bit shy, of course. And we have a fair bit of epoxy here, so I'll probably have to pull the Dremel out again and go through that area. No, actually we're okay. Perfect. Excellent. So that little extra piece that I left there, that is perfect because that lets our box that we're gonna build butt up to this former, and it creates a perfect little lip. Awesome, that is wonderful. That worked out really well. Happy with everything there. So just gonna spend a little bit of time cleaning this guy up. But otherwise, it is wonderful. And then once we get our box installed in there, that's all going to be high solid in place. So that'll actually completely restore and add more structure than this piece had. So now the downside of using these guys is they're quite thick, as you can see there. They're compared to just the fiberglass that we have in the replacement pieces. So that's one of those scenarios where it may not make sense to use this just because of the design and the space limitations that we have here. So we're just working on this piece by piece, and I'm just going to get all of these pieces put together individually. So we've got the first piece there, which is the front piece. It's kind of our most important piece. And the reason for that is that's where our front of our doors butt up against, and that is also where our pins that lock everything in place are going to sit. So I've molded that bottom section to fit nicely, and we'll put another doubler piece there, so right along here, and that's going to provide a stop for those doors as well too, because that area is a little bit tricky. The rest of the areas we can put G10 material here, which also helps to stop those doors. But the way we're going to do these doors is kind of the typical CARF way of doing it. That's what I call it anyways. So basically there's going to be we'll just pretend those doors are installed there. There's going to be a pivot point with a tube and a pin here and right about there, just like we have done on the other doors. So then what happens is they open like this. So those tail ends disappear into the fuselage. So it's just a really nice way to make those doors work. And then they'll also be removable as well too, because the pins will come in like this and like that. So, and then we'll do this, of course, the same thing on the other side too. So, all right, so our side is shaped there. That's an interesting one. We've got to sand an angle into the front and a little bit of shaping on the bottom section. So just doing piece by piece, it's working out okay. Next one we're going to do is this side runner down here. So what I do is I take this out and I measure the height here and then cut a long piece, and then we just shape it to fit that spot. All right guys, we got our box tacked together, and just putting the pipe in here, kind of getting it centered, and top bottom we are kind of equal space there. So basically the pipe is resting on that back corner, which is actually a little bit high anyways. So I'm going to sand that down a little bit, but that tells me that our spacing is good. We left just enough space for that pipe, which is great. Awesome. All right, so I've been going back and forth on the hinging mechanism for the chute doors, whether I was going to use this style of hinge, the little Dubro plastic ones, or the CARF pivot that we've been talking about, and pretty much decided that we're going to use the CARF pivot. So part of the reason for that is if we use those Dubro hinges, number one, we've got to get rid of the foam on the inside here. The reason we have to get rid of the foam is we need those hinges to be as close to the external surface as possible. Other thing is you're going to end up wherever those hinges are. In order for this to open properly, we're going to have to cut a relief into the door. That's not really a big deal, but when these are closed and we're using the other pivot method, like what you see on the gear doors, for example, So sort of like this version here, except that pivot is going on the ends of those doors, but same kind of theory. So what happens with that style is when they close perfectly. It's so much nicer and prettier, and I think it's going to be more solid for this door setup. The other thing it allows us to do is to use the existing doors that we cut out of the fuselage. So it's going to blend really well. Using the previous doors that are already weathered and everything and shaped. The biggest thing is the shape here, right? These guys aren't shaped, they're just like a flat piece of fiberglass. So yeah, better way to go. That's what we're gonna do. So I'm gonna work on getting these parts set up. So first thing we have to do is get some piano wire and some suitable brass or nylon tube to receive the piano wire. All right, so door setup 101. So we've got our doors cut out, and they're taped back together and they are placed in the opening. As you can see there, we've kind of got the space evened out front and back. We've got a nice big gap down the center, so we can play around with any of the gaps that we need afterwards on the edges here. But the first thing is making sure that we get this positioned where we want it before we glue our other pieces in. So we've taken a piece of piano wire and some carbon tubes. Now you can really use whatever you want for receiver tubes. You can use some of the Nyrod tubes, the plastic ones. You can use brass. This small carbon tube that I had in stock here just happens to fit this thick piano wire very well. So essentially what we're doing is we are getting, if you can imagine, this is the door and this is the fuselage here. And our pivot is right here on this side. Essentially what we're going to do is we're going to glue this in like that. So with that door positioned in the right spot and gluing these pieces in, we don't even need to use our pin right now. Now we can put a pin all the way through to make sure that everything lines up well. So that's an option as well too, but basically what we're doing is we're getting these guys glued in place. And then what we do afterwards is we take our Dremel and from the outside of the fuselage, we cut through these carbon receiver tubes, and that now separates the two once the glue is cured, of course. And then from there, we're able to take these pins and install them, and it's a quick release kind of system where they're easy to remove. And the other nice thing is the pivot is away from the joint, so these operate very well. When these open, it's usually a zero clearance issue where it's hitting the fuselage. So very nice way to do things, and that's how we're going to make this work. So on our receiver portion here inside the fuselage, we do need to make some holes in this former work where our pins are going to go through, because there's only a tiny little piece there. Anyways, those pivots need to go through the former and they'll stop on the other side. Now wherever those pins interfere with our box, our chute box, we can just do a little cutout. That's not a big deal at all. And yeah, so that is basically what we're doing here for the doors. And the other thing too is we can take the pins and we can go from the outside, so they can go from this side of the former and they can go from the back end forward. So it's going to be a great system, I think. And what we're going to do now is get these guys spot glued in place, and then we'll mix up some High-Sol and get those High-Soled in place. All right, so we've got our holes done through the former work here. We've got the fuselage sanded out where the pins are coming on the back side, and then we've also sanded out the door where those pins are going to get glued down to the doors. So now what we'll do is we'll get this door installed. We're going to tape it from the outside so it's nice and positioned, and then we're just going to spot glue those pins in with some CA. Now what I did was I took a this is one of the CARF Rebel nose pins, and this is going to allow us to get those pins completely aligned before we install them in the fuselage. All right, so we got all of our pivots installed. So those are of course glued on both sides of the doors. So those are all solid now. So what we're going to do is we're going to flip this fuselage over, and we're going to use our Dremel and slice through those guys. So that's just going to make a nice clean cut on each of the 4 corners. So we'll get that done. You could also use a Zona saw, or a razor saw, but the Dremel's nice and quick. All right, so we've got a little bit of progress here. I ended up going with the single piece rods. Those are actually the nose pieces out of CARF Rebel Classics that hold the canopy on. We don't use them, we use a different system. So there's the front end, the balls. So that'll actually work out good. And I did cut them down a little bit, but they're the perfect size, so that's great. We cut the grooves in between our doors. So right here, there's a little bit of cleanup on the foam there, you can see, so they move freely. And then the last thing I did was get our stops added. That's the G10 stops on the front and the back of the door. And those prevent the doors from coming in too far. So I made sure I taped those doors closed perfectly before we glued those G10 pieces on. The front ones here are actually far more important than the back ones, because the back ones are going to be pushed out anyways a little bit with the cable coming out of the chute. But the front one is very important because you want that to be nice and flush with the fuselage. So those parts are done, and I think we are ready to glue our box in place. Now before I did all this stuff, I made sure that the box going in didn't impede the doors from operating. We're going to have to sand out the center sections because the extra height from the G10, so I'll do that. But with this box fit, the doors operate wonderfully, so no issues there. So I'll take my Dremel and we'll just sand out these center parts here just a little bit, front and back, to allow this to sit down properly. All right, so we are working on our actuator here. So I took a section of stainless tubing and heated it up, added a bend on here. So my thinking behind this is to have a servo mounted here, the servo arm sitting right here. So we use like a flat mounted servo, and then that servo is going to pull back. That's going to pull this arm down. We'll have a linkage, of course, going in between those. And then we'll have a flapper like this mounted on that side, I think. And that is going to push down like that. So it's going to push the chute out of the system here, the holder. So the point of doing this versus making this spring loaded is the spring would eventually wear out. Now we could make this into a spring if we wanted to. That would also be possible as well. So we haven't counted that out yet, but at least this gives us that possibility. So in this case, we'd have to put the spring here, bring it down, attach it to over here somewhere, and then that is pulling it down like this. So when we loaded this back up, we'd have to push it up like that, push the chute in, hold the doors closed, and arm the chute back, which means the servo would push its 2 pins back in there. So haven't counted the spring-loaded system out yet. We'll think about that. This gives us options at least. So now what we need to do is we need to make some sort of extension on here that comes out that allows the arm to push down on this piece of flapper. So pull this out here. So basically we want to have some sort of extension piece like this, just providing extra structure or support onto this piece of wood. Because if we just high-soled this area here, that's not a lot of contact area for this. So I'd feel more comfortable if we had just one extension piece. So I just need to get a hole in here where I can high-saw this all together, and it's going to work well. All right, so I don't know the size of the chute yet. I'm kind of just guessing that that's going to be enough space, but based on my experience of the other planes that we've put together, I think that whole area is going to be enough space. When this is pushed up all the way, because we're going to have the top plate on like this, just this G10 top plate. So that's as far up as that is going to sit. So this is our space for the chute. Now I started off just using this scrap piece here, and you can see I maximized the space that our piece could take up. Now because of the geometry here and the way this is shaped, you couldn't really make it fit the whole space, but at least it's enough where I don't think we're gonna have, you know, you wanna prevent having the chute tucked up here kind of thing, but I think that's gonna be good. We can have either a spring or servo actuation here, and it's gonna come down to that point right there. So what it looks like from the top side or the underside looking up is like that. So I think that's gonna be enough to pop that chute out, especially if it's quick. You know, the doors open, for example, or I guess the doors unpin themselves. This servo goes pop to there and pushes the chute out nice and quick. And we're not relying on a spring if we use a servo operation to make that work. So we've just got this all spot glued in place right now. And yeah, next step would be to, I think, to glue this in place. We need to put a collar on here as well too, so this doesn't slide out, but I think that is gonna be fine. All right, so lots accomplished today with everything there. That's good. Happy with that, very, very happy. So we've got the box and everything glued in place with copious amounts of West Systems 610. The reason I use the West Systems 610 on this scenario is because we've got the long mixing nozzle and we used a lot of glue in this area. You can see there on the rod that holds the plate to everything. That's got a lot of high sol on it. Probably excessive, but that's okay. And here's a shot from the inside. So we've got all of our wood inside glued. We've got the sides all tooled nicely. So we're gonna let that cure now overnight, and we will come back tomorrow and see how everything is doing. So big steps accomplished today. That's great. All right, so it's been a couple days. Everything's nice and solid with our chute mechanism here, so that's good. We're hanging up a little bit right there, so I'm just gonna check and see what that is, if it's our excess glue back here. I think we've got lots of space in the front, so it's probably just where I put the glue around the rod, but anyways, that's nice and solid. So I also added this morning a mount here for our actual chute fixing. So that has been high soled in place. That's aircraft ply, 1/4 inch. So what we'll do is we'll have a hole right back here. We will put through the hole a little piece of brass tubing, so over time the cable that comes out of here doesn't rub through the fiberglass, and then that cable comes down and goes in the chute mechanism down here. So that's what we're gonna do. We're basically gonna be using a Dubro pull cable system is the best thing to do. So it's gonna have like the nylon covering on it, and we'll just make that cable up, and it's gonna be long enough where it goes through the hole, down the side of the fuselage, fits into the chute mechanism. It's gonna have a loop on the end, and then our chute can attach to that metal piece. So it's gonna be nice. Even if there's not a chute in there, the cable will be on the external part, and you can see the cable out there as well. So next thing we need to do is get our door set up here sorted out. So the door, or the top piece, I guess is the better way to say it. I kind of did the shape of it previously, so we can get that all done. I don't know if there's any reason to glue it down or not glue it down. Like, I don't think it would be the end of the world just to glue it down. It's really not doing anything because this piece is only gonna go so far. So yeah, I'll probably, I don't know. We'll figure that out. Anyways, that's not really a big deal, but that's there. We're gonna cut that to fit. And then our servo is gonna get mounted on the back plate here next. All right, so working on the servo setup here. So the goal is to have this servo mounted right in that spot right there. And when this is in the up position, so push back like that all the way, I want to have the servo mechanically locked. So if you're not familiar with what that means that when this is in the up position, the servo arm's in that position, our ball joint or clevis on this side, ball joint on the other side is sitting in this position, and then our arm or ball joint on the other end is like this. So the servo is not holding any load when the chute is up. The only time it's going to be loaded is when this deploys, and then it's going to reset. So it's going to be very little load on the servo always, which is what we're looking for. So we got this part set up. We're using a 3mm rod. We're using a golden clevis in the metric size. And then we'll put a ball joint on the other side of this, and that will connect to the rod itself. Now the nice thing about using a ball joint in our rod up here is that we can basically just glue a bolt in there, and it's going to be super simple. And then we'll have nice angle on this ball joint as well too, because that ball joint's got to angle down towards the servo. So should be a good setup. I think that that'll work very well. Nice and simple. Yes. All right, so working on our sequencer here for the chute. So what I've done is this is our servo that's going to do the flapper. This is our servo that's going to do the pins that hold the doors open and closed. So I'll give you a brief rundown here of what we did so you can understand this if you're a jetty person. So if we go into model, first of all, we'll see the setup here. Let's take a look at it. So what I've done is I've added channel 16 or function 16 and 17. So 16 is chute lock, which is this guy, and then chute deploy, which is 17, which is this guy. So deploy is the flapper. So we've got that all set up. This guy, because I've already been playing with the limits and stuff a little bit, we've got them kind of tuned down a whole bunch. So that's why you'll see this one only move a little bit. So now that that's done, we've got the servos plugged in, obviously, and we are going into our advanced properties, and we're going to use the sequencer for this. Now the reason we're using the sequencer is because we want the doors to open, chute, plunger to push, and then come back up. We taxi back from our landing, bundle the chute up, put the chute back in the holder, and then we close the doors. So you'll see how the sequence works here once I operate it. So right now everything's packed away. We land, we want to deploy the chute, we flick the switch. So doors unlock, chute plunges down, and then resets. I'll do that one more time for you so you can see it. So chute's going to open, and then plunger comes down and then resets. There we go. And then we taxi back, we flick our switch back, and doors lock. Now this is going to be way too much travel, but I'm just keeping it there to show you. So now that we've got the basic functions set up, we, at a later date when we get into the programming, we'll talk about the logic stuff that we're going to add behind it. But basically what we're going to do is we're going to have a logic 1 and a logic 2 set up. So logic 1 says that gear needs to be in the down position and flaps need to be at full flaps. That's logic 1. And that's tied to the chute, sort of. And then we set up a logic 2. Logic 2 says that logic 1 needs to be met and SM, which is our switch we're using, needs to be met. So the chute won't deploy until logic 1, all those conditions are met, and our switch is moved over as well. So we'll get into the details of that though when we set that up at a later time when we do the programming, but at least right now with this stuff set up we can get our servos and all of our functions and functionality figured out in the aircraft. So we're going to start off with our plunger setup here. So I haven't put our cover plate on yet. The reason I haven't put our cover plate on yet is because I want to be able to see this and manipulate it and do that kind of stuff. So that's why we have that sitting where it is. All right, so we got everything set up with our sequencer for the plunger. Still have to glue the ball joint into the big metal rod, but I'll show you guys what it looks like here. So I flick my switch. So right now we're reset. Chute is all installed and everything. Flick my switch. Comes down, pops back up, reset, and here's a shot from the underside. And then a shot here of the actual sequence. So right now we're off. We're at minus 87%. I'm going to flick my switch. Plunger goes down. Plunger resets. And when I reset my button, my door servo closes or locks. All right, so a little more progress here. We did a little bit of sanding on our front door retainer piece just to make some space for our closer pieces, which are little pieces of wood that pins will push through. And we've got our doors set up here. So I got rid of the foam on the door, so the piece of plywood would be glued and fastened right to the actual fiberglass. So we did that on both sides, of course. And just because this is such a critical item, rather than just relying on the glue, we also put a screw countersunk, BVM little hatch screws through there. So now those pieces of wood are nice and solid. We'll put a little bit of aero epoxy on there as a final step, which we have to do on these carbon receiver tubes as well, but that'll come later once we get everything set up. So the theory behind this is, of course, this door gets installed and then we drill through the former that's right in front of this door, and there's going to be a pin that pushes and comes into here, which is servo operated. So that is the plan with all of that. So here's a shot of what I'm thinking about for the lock system. So we've got our holes drilled through the former work, and we've got the hole drilled through the box right there, and that's engaged with the locking mechanism. So when this opens, essentially this door, everything's really tight right now too, so keep that in mind. So this slides forward, releasing the lock on the door, and the doors flop down. So we got both of our pins set up. The height and everything is set up perfectly. So it's nice and solid when those go in there, which is great. We've got our rods both run forward. Now those rods are the same distance back here. That little L bend we can cut off, so that's fine. So those go through the former right there. Now, of course, if you were taking this horizontal stab on and off, that's going to be an interference for sure. Pretty sure based on my calculations that this is low enough that it's not going to be an issue, because our horizontal stab piece is just as wide as that carbon plate, and then it's only about this thick. So there should be tons of room in there for that. That won't be a problem. But what I'm going to do is I'm going to make, I think, a sort of a disconnect system. So if this does ever need to come out, it is possible. And that's going to happen on the front here. So we've got lots of extra wire, piano wire coming to the front. So what I'm going to do is I'm going to mark these guys at exactly the same spot where they kind of meet, just like there. And then we will probably solder those two pieces and a threaded rod together, and then we'll have a connection point at the servo, so then at least it could be disconnected from the servo, and we can lift these guys up and pull them forward, disengaging all that stuff. So of course it's not going to be super easy because you'd have to reach your hand in here, but we just want to make it possible just in case. So we took the rods, sanded the ends down, took a piece of brass tubing here, a piece of threaded rod, and got that all put together. So now this is one piece, and these are the pieces that slide in between the horizontal stab and lock the doors in place. So this is our release system here, if you will. So what we're going to do is we're going to put a ball joint on this end, and we are going to be using an HV69 servo. So what we're going to do with that is we're going to use an aluminum servo arm, but we're basically doing something like this, where this is sitting in the mount kit that comes from our website. Speaking of that, we do have a lot of funky things like this on our website, so check it out, thelightersideofrc.com. Sort of trying to update that on a regular basis, but it's been a while since we've put stuff on there. But we do have some classics like the wood servo mounts in 3 different sizes. So definitely check them out, thelightersideofrc.com. Yeah, so we'll get this guy built, and what we can do essentially is we get the servo set up in our locked position, get the ball joint and everything hooked up to this. That's how we determine where to glue this down, because the spot really doesn't matter. And then we just adjust our limits on the other side. So it's going to be super simple to get this guy adjusted, which is perfection. So let's find an aluminum servo arm and get this guy built. All right, so the lock setup is done. So sort of the quick release here is the bolt here can be taken out, and then these guys can just be slid forward. It's not obviously super quick release, but at least it allows us to get the horizontal stab on and off by pulling those rods forward. So that's good. We've got everything kind of hooked up here so I can show you guys what it looks like. So that is of course the locked position, and I've just adjusted my servo limits here, added a little bit of slowdown on that servo when we're going back to the lock direction. So that's the negative side there, you can see. So it opens real quick, and then when we're resetting everything and closing the doors, it goes 2.5 seconds to go back that direction. So there's our servo limit set up, but if I adjust this, you'll see, so we're going to drop the chute, or open the chute, so it opens quickly, and what this does is this brings the rods right to the edge of the plywood in the chute holder, and if we reset everything, so we're going to go back the other direction, takes about 2.5 seconds. And the nice thing for that delay is it just allows the rods to kind of sneak in nice and slow rather than jamming themselves into the plywood. This is just, the mount here is just CA'd in place. Probably fine, but once we do some epoxying or high soling, we'll come in and put some high sol around there. Awesome. Very happy with this setup. It is working out good. So what I can do now is I can hook up the back servo to port 17 here, which is our push down or plunger chute. So we still haven't glued that in place yet, the rod and stuff, but I can make sure that this timing wise works. So chute deployed, awesome. And the plunger has reset, and we taxi back, we fold the chute up, we pack it back in the thing, we close the doors, and then we lock the doors. Awesome. All right, so that makes me very happy that we got that stuff figured out. It's a big hurdle, a big step for this aircraft. Next thing we'll do is we'll get our cable set up so that is ready to go, and we'll get our doors set up. So I'm gonna get that stuff queued up here and I'll show you guys what that looks like. So all of our high sol work is done. I'll take you guys through what we did here. So we've got our brass insert installed in there, and just put a little bit of high sol at the base of the insert. Kind of see it right there in the center of the screen. Not that that's a big thing, but that's an important one. So we got our cap installed on the chute housing. So that's done. That was a bit tricky because I used CA and high sol. So you can see like the corner here is done with CA. So I did my high sol around the perimeter, and I left some spaces for CA, put some thick CA, dropped it in place, sprayed some kicker, and now it's just curing. So we got our rod installed in the shaft there, so that is done. Also got the doors reinforced as well too. This is kind of an important step, I think, because these doors are pretty flexible. So I sanded these out previously and laid down a layer of thick fiberglass cloth, like maybe 4-ounce type cloth, just to strip down the center there. Obviously with high sol, we're letting this cure. These doors will get painted. We're also going to shape those lock things just to make them more rounded and stuff, but we have to wait for everything to cure, obviously. So those are good. They sit nicely in the perfect position when they are just resting. So they're pretty flexible when they're in there. So I wanted to make sure that we added another layer of stiffness just to make sure that when the chute's in here, it's not deforming those doors. And then moving to the front side of the rear section here, we got some high sol installed around the perimeter of that servo. So that is basically all of the gluing for the back end at this point, which is awesome. Wicked progress. And that, guys, is going to wrap up video number 4 in the CARF Composite ARF F-100 series. This thing is super cool. Really excited that we got the chute mechanism all figured out and solved. That is a huge step, and I wanted to make it the focus of this video. So if anybody's looking to do this type of thing on this aircraft or any other aircraft, it can be used as a resource for you guys. If you're looking for a chute for an aircraft, we also have the chute en route from Carlos at CM Jets. He's the guy that's doing up the chute for us for this aircraft. So thank you, Carlos, for that. We'll feature that obviously as we progress through this this build and video series, but things are going very well with this aircraft. So really excited to start moving forward. We're still waiting on those ball joints for the horizontal stab, which kind of isn't a lot of fun, but we're making it work. Next video, we're gonna start to move into some of the detail work that still needs to be done. So what I'm thinking about doing is the lights. A lot of those lights need to happen on the main part of the fuselage. There's some on the wings, of course, and stuff as well too. So we're gonna move into that. We're also gonna do the wiring in the back end of the aircraft. So in this guy here, we're gonna get all of our wires done, afterburner wires run, and basically everything positioned and ready to plug in. I wanna have this thing ready to go 100%. So all we have to do is do our elevator servos, that linkage to the horizontal stab, and that's it. So that's the goal with this. So next video will be very, very focused on some of the detail work. Thanks guys for watching. Channel members, thank you for being channel members. If you're watching this and you're curious what channel membership is, there's some links down below in the video description that takes you to channel membership. It's a paid thing, but our channel members get to see all of our videos early on YouTube. So in the case of this F-100 series, as we work through this, we're like a week to 2 weeks ahead of schedule. So they're seeing all those videos early. So check out channel membership if you're interested. Thank you, channel members. Thank you everybody for watching, and we'll see you in the next video. I'm very excited to see everybody at Turbines and Tumbleweeds in Sweetwater, Texas, October 2nd to October 5th, 2025. See you there.